Welcome to Current SCHEM World. Good morning. In this video, let us study neutron activation analysis. What is neutron activation analysis? What is its principle? Okay. What are the advantages and applications, etc. Okay, let us first study neutron activation analysis and its principle, how it works. It is based on the nuclear reaction between target nuclei and thermal neutrons. For example, the target nucleus is bombarded with the thermal neutrons. It undergoes neutron capture to give compound nucleus. This compound nucleus is transformed into radioactive nucleus, which may emit beta emission, which may emit beta particle, and it emits gamma rays. From the gamma ray energy, we can identify the element present, and from the intensity of gamma ray emitted, we can use it for determination of concentration of the nuclei in the sample. We will see in detail. The induced radioactivity A after irradiation for time t is given by the following expression: A equal to n phi sigma 1 minus e power minus lambda t. Okay, in this A is the radioactivity, induced radioactivity, and it is directly proportional to neutron flux, that is neutron intensity. Neutron flux means neutron intensity. Neutron flux is more, means more number of neutrons per centimeter square per second. Okay, and then sigma equal to neutron capture cross section in centimeter square. For example, if the nucleus is bigger, then cross section, nuclear capture cross section will be more because of the size. Okay, so sigma equal to neutron capture cross section per centimeter square, and lambda is nothing but disintegration constant or decay constant. Now let us see the important features of neutron activation analysis. Okay, this is the schematic of neutron activation analysis. In NAA, the target nucleus is bombarded with the neutrons. During irradiation, the naturally occurring isotope are transformed into radioactive nucleus by means of neutron capture. Then the radioactive nucleus decays according to its characteristic half-life period. If it has less half-life period, then it will disintegrate very fast. If there are nuclei with a high, large half-life, then it will take 2 days, etc. And some nuclides emit beta particles only, but all nuclides emit gamma ray, photon, gamma rays with specific wavelength and specific energies. Okay, that is used for each element will give specific gamma ray photon wavelength of specific wavelength. And the quantity of radioactive nucleus is determined by measuring the intensity of the characteristic gamma ray, or from the height of the peak in the gamma ray spectrum. We will see in the next slide. Let us now see gamma ray spectrum analysis. This is the gamma ray spectrum of a sample, which consists of several elements, as you see. Okay, it consists of manganese and sodium and a little amount of magnesium. The intensity, count intensity. From the intensity, we can say how much is present, and from the gamma ray energy, gamma ray each each element will give specific gamma ray energy. From the gamma ray energy wavelength, we can identify the element present in it. Okay, gamma ray spectrometers are used to determine the counts, number of counts, and intensity, energy of the photons emitted by the radioactive nucleus. The peak position or peak location and the peak area or peak height in the spectra have to be determined. The peak position corresponds to gamma ray energy to identify the nucleus present in the sample. For example, manganese will emit gamma ray of this energy 800 keV. Okay, while the peak height or area is proportional to the concentrations of the various elements present in the sample. Okay, let us see advantages and applications of neutron activation analysis. It is useful to determine the chemical composition of a sample, for example Mars samples from Mars or lunar samples, artifacts, forensics, biological samples, etc. It can identify up to 74 different elements. It can be carried out in solid state, liquid state, or any state mixtures. It can also determine the concentration of elements of interest. The sample size is very low, so we need just 0.1 ml or we need 0.001 gram. So it is very highly sensitive, high precision technique, and it is non-destructive method because the sample can be reused. It can analyze simultaneously multiple elements present in the sample. It does not need chemical treatment or sample treatment. You can directly use in the nuclear reactor, and it is useful for both qualitative and quantitative analysis. Thank you for watching. Please share and subscribe. Thank you again.